You step outside on a quiet night, away from the buzz of the city, away from the glare of streetlights and the constant hum of life. You climb a gentle hill, take a deep breath, and lift your gaze. What greets you is darkness, a deep, velvety black sky, sprinkled with tiny points of light we call stars. It's breathtaking, almost poetic. Your intuition whispers a simple truth. The sun has gone down, so naturally, it's dark. It makes sense, right? But here's the twist. Your intuition is misleading you. That darkness, that calm night sky, is not just empty or serene. It's one of the most perplexing and unsettling puzzles in the history of science. If the universe worked the way scientists thought for centuries, if it followed the picture painted by Isaac Newton, the sky shouldn't be black at all. It should be blindingly bright. Imagine this. Every single patch of the sky, every point you look at, glowing with the intensity of the sun's surface. The night sky shouldn't feel peaceful. It should be an inferno. You should be seared in an instant, unable to bear the light. Yet, here you are, shivering slightly in the cool air, marveling at the quiet darkness. This paradox has tormented astronomers for hundreds of years. Why is the sky dark? To answer, we have to rethink everything we thought we knew about the universe. We have to dismantle it and reconstruct it, realizing that what we perceive isn't a still painting, but a dynamic, ever-changing cosmos. Let's dive in. Before we unravel the solution, we need to grasp the problem fully. Why would anyone claim the sky should be ablaze with light? At first glance, it seems absurd. The stars are scattered across the sky, tiny and distant, and the space between them is vast. Clearly, the sky is mostly empty. But let's use our imagination rather than equations. Picture yourself in a forest so dense it stretches infinitely in every direction. You look around and you see tree trunks everywhere. At first, you glimpse some gaps, glimpses of sky. But look further, and there are more trunks, and more beyond that. If the forest never ends, your line of sight will always eventually hit wood. You cannot see the sky. It's completely blocked. Now, replace each tree with a star. If the universe is infinite in size, with stars scattered evenly, and if it has existed forever, every line of sight from your eyes should end on a star's surface. Wherever you look, even into the dark patches, there should be a star waiting at some distance. Every point in the sky should blaze like the sun. It's not just a little brighter than expected. It should be an unstoppable wall of light. You might object, but the distant stars are dimmer. They aren't as bright as the sun because of distance. A fair point, but let's examine it closely. Yes, the light from a single star dims with distance, obeying the inverse square law. Move a star twice as far, its brightness drops to a quarter. Move it 3 times farther, it falls to a ninth. So distant stars do get fainter. But here's the cosmic twist. The further out you look, the more stars there are. Imagine a hollow shell surrounding Earth, a thin layer of space at a certain distance. Count the stars inside. Now double the distance, and the shell's surface area quadruples. If stars are evenly distributed, there are 4 times as many stars in that shell. Each star is dimmer, but there are more of them. The total light from that shell? Exactly the same as the first. Add a third shell, a fourth, a millionth, and you are summing infinite layers of light. In an infinite universe, the sky should be ablaze. The dimming doesn't save us. The math perfectly cancels out. It's like the universe is playing a joke, conspiring to fry you with light. Yet, look up. The sky is dark. One of our assumptions must be wrong. Perhaps the universe isn't infinite. Maybe the stars have an edge, a boundary. That seems unlikely. Nature doesn't build invisible brick walls in space. Maybe the stars aren't evenly spread. They could be clumped. But telescopes reveal large-scale uniformity. Could cosmic dust be hiding the distant stars? No, because if infinite light hit the dust, it would heat up and glow as brightly as the stars it hides. Energy cannot disappear. It only moves. Dust is out. We are left with a paradox that challenges the very foundations of existence. But paradoxes are treasure maps in science. They indicate missing pieces, hidden truths waiting to be uncovered. That missing piece? Time. The piece of the puzzle that changes everything is that the universe has a beginning. In the days of Newton and the thinkers before him, the universe was assumed to be eternal, an infinite, unchanging stage ticking away like a clock forever into the past and forever into the future. But the dark night sky tells a different story. That darkness whispers a truth our ancestors could not see. The universe is young. It had a birthday. And once you realize this, everything about the paradox starts to make sense. If the universe began billions of years ago, then the light from the most distant stars has not had enough time to reach us. Light travels incredibly fast, 186,000 miles per second. But even at that speed, the cosmos is vast beyond comprehension. When we look at a star 4 light years away, we are seeing it as it was 4 years ago, not as it is today. The star we see is a ghost from the past, a snapshot frozen in time. If the universe is finite in age, there's a limit to how far back we can see. This isn't a horizon of space, but a horizon of time. Picture the universe as full of stars, stretching infinitely in all directions. But if those stars only switched on 13 or 14 billion years ago, we can only see the ones whose light has traveled far enough to reach us. Any star whose light would take longer than that to arrive, we haven't seen it yet. It's racing toward us, crossing unimaginable distances, but it hasn't made it. In this way, we exist inside a bubble, a sphere of observable stars, bounded by the age of the universe. Within this bubble, the number of stars is finite. There aren't enough to fill the sky with an unbroken blaze of light. The gaps you see between the stars are real. They are the darkness of the cosmos before the stars were born, the void that existed when time itself was just beginning. But even this explanation only takes us part way. There's another factor that makes the universe stranger still: expansion. The universe is not static. It's growing. Edwin Hubble first observed this phenomenon, though the underlying principle was already embedded in the equations of relativity. Space itself is stretching. Imagine baking a raisin cake. As the dough rises, the raisins move apart, not because they are traveling through the dough, but because the dough between them expands. From the perspective of a single raisin, all other raisins seem to recede, and the further away a raisin is, the faster it appears to move. The universe behaves the same way, but on a scale that dwarfs imagination. This expansion stretches light. Light is a wave, a ripple in the electromagnetic field. The wavelength of the wave determines its color. Blue light has short, choppy waves. Red light has long, rolling waves. Now imagine a photon of light leaving a distant galaxy, traveling toward Earth across billions of light years. As space expands, the wave itself stretches. It's like drawing a wave on a rubber band and then stretching the band. The crests get pulled apart, and the color shifts toward red. For extremely distant sources, the stretching is so extreme that visible light shifts into infrared and eventually into radio waves. The light that might have filled the dark gaps in our night sky is diluted, shifted beyond the range of human vision, weakened by the very fabric of expanding space. So two factors combine to keep the night sky dark. First, the universe hasn't existed forever, so light from the farthest stars hasn't reached us yet. Second, space itself stretches, draining the energy of the light that does arrive and shifting it into invisible wavelengths. We are protected from the blaze of infinite stars not by luck, but by the fundamental structure of the cosmos. This leads to a profound realization. The spaces between the stars, the gaps you see in the night sky, are not empty. If our eyes could detect microwaves instead of visible light, the sky would be glowing. It is filled with a uniform, constant radiation, the afterglow of the Big Bang itself. This is the cosmic microwave background radiation, the oldest light in existence. It is everywhere, bathing every corner of space but invisible to our natural sight. This faint glow is a message from the birth of the universe, a relic of the fireball that existed before stars and galaxies even formed. The Big Bang wasn't an explosion in space. It was an explosion of space. At the very beginning, the universe was hot, dense, and opaque. Light couldn't travel freely. It bounced around like pinballs. Then expansion and cooling transformed the universe into a transparent cosmos, releasing that trapped light to stream across space. That radiation has traveled for billions of years, and though its visible intensity has faded, its presence is still with us. Every inch of the universe carries it, whispering the story of its own beginning. Even though the night sky appears dark to our eyes, it is anything but empty. That faint cosmic glow, the cosmic microwave background, is a relic of the earliest moments of the universe, a constant reminder that everything we see today emerged from a singular blazing beginning. Yet, because humans can only see a tiny slice of the electromagnetic spectrum, we miss it entirely without the help of instruments. This highlights something fundamental about how we perceive reality. We are trapped in a middle scale. We are not small enough to experience the chaotic quantum world, where particles flicker in and out of existence and can occupy multiple places simultaneously. We are not large enough to intuitively grasp the bending of space-time or the slow, imperceptible dance of the universe's expansion. We exist in a comfortable intermediate zone, perceiving only a sliver of the full reality. Time, too, is more complex than our everyday experience suggests. The fact that the universe had a beginning implies profound truths about the structure of time itself. We tend to think of time as a river. The past is gone, the future is yet to come, and only the present moment is real. But physics, particularly relativity, forces us to reconsider. Imagine time as a block, a giant cosmic sausage stretching from the Big Bang to the ultimate fate of the universe. Each slice of the sausage represents a moment in time. The now we experience is a thin slice cut from that sausage, containing all the stars, galaxies, and beings of the present. But here's the twist. Observers moving at different speeds experience differently angled slices. Your now might intersect with my past or my future. Time, in this view, is not a simple flow, but a landscape in which past, present, and future coexist, just sliced differently depending on perspective. When we look up at the night sky, we are gazing down the length of this cosmic sausage. The starlight we see is not a message from the present, but a glimpse into the distant past. Some stars may have already burned out millions of years ago, their current existence lost, yet their light still travels across the void, delivering news of their former lives. Every moment, we are reconstructing the universe from delayed signals. Even the people around us, every object we observe, exists slightly out of sync with reality. What we perceive as the present is always a reconstruction of the past, delayed by the finite speed of light. It is unsettling, almost disorienting. Our perception is never instantaneous, always lagging behind the truth. But this delay is exactly what saves us. If light were instantaneous, the entire energy of the universe would hit us at once. We would experience the combined radiance of infinite stars, the intensity of the Big Bang itself, and the night sky would be an uninhabitable furnace. The finiteness of light speed and the finite age of the universe act as a natural shield, allowing stars to form, planets to cool, and life to exist. The darkness of the night sky is not a deficiency. It is a prerequisite for our existence. If the universe were fully illuminated by every star, life as we know it could not survive. In that sense, the darkness above is both protective and revelatory. It is a gateway to understanding the cosmos, a hint that the universe is young, expanding, and dynamic. From a simple observation, the absence of light, we can infer the Big Bang, the expansion of space, the limits imposed by the speed of light, and even the very nature of time. You don't need a massive particle collider or a billion-dollar observatory to engage in profound physics. You just need curiosity, patience, and the courage to question your instincts. Common sense can mislead. It is shaped by experiences at human scales and times, but the universe operates on rules far beyond those limitations. The night sky, when interpreted correctly, tells us the universe had a beginning. It has been stretching ever since, and its oldest light is all around us, waiting to be detected. Standing under it, we are witnessing the cosmos in motion, experiencing history that spans billions of years, compressed into the faint, scattered points of light above. The dark spaces are not empty. They are the fabric of time and space itself, stretched and expanded, forming the very stage on which our existence unfolds. It is in this context that the universe becomes both absurd and magnificent. That simple observation of darkness leads us by the hand through the deepest insights of physics, astronomy, and cosmology. From the absence of light, we trace the universe's origin, its ongoing expansion, the nature of space-time, and the cosmic forces that make life possible. We begin to see ourselves not as separate observers, but as participants in the unfolding story of the cosmos. The darkness is not just a backdrop. It is the echo of creation, the quiet witness to the universe's youth and dynamism. Now let's explore how this expanding universe shapes not just the light we see, but our very perception of existence. The universe is not static. It's growing, stretching, and reshaping itself every moment. As space expands, it stretches the waves of light traveling through it. Light, as a wave, has crests and troughs, and the distance between these crests, the wavelength, determines its color. Blue light is compressed, rapid, and choppy. Red light is stretched, slower, and long. When photons from distant galaxies race toward Earth across billions of light years, the expansion of space pulls on those waves, stretching them. This is redshift. Light from faraway galaxies shifts toward the red end of the spectrum. For the most distant sources, the stretching is so extreme that visible light becomes infrared, then radio waves, completely invisible to our eyes. This is why the gaps between stars remain dark. They are not empty, but filled with light our eyes cannot perceive. This interplay of distance, time, and expansion preserves the darkness that makes life possible. Were it not for the finite age of the universe and the finite speed of light, we would see every star simultaneously, and the cosmos would be intolerably bright. Instead, the night sky is a tapestry of gaps, a delicate balance that allows atoms to clump, stars to form, and planets to cool. Darkness is the canvas upon which the universe paints the possibility of life. Every dark stretch between stars is not an absence, but a record of the universe's youth, a snapshot of light still racing toward us across unimaginable distances. The night sky is more than a spectacle. It is a history book written in photons. When we observe the stars, we are looking back in time. Each point of light tells a story of existence millions or even billions of years ago. Some of the stars we see may no longer exist in their current form. They burned out eons ago, but their light continues to travel, allowing us to witness their ancient existence. Every glance upward is a window into the past, a reminder that reality is always reconstructed from delayed information. Even the people we see, the objects we touch, are all experienced slightly out of sync, filtered through the finite speed at which information travels. This delay, paradoxically, is a blessing. It shields us from the raw, unfiltered energy of the universe, giving life the room it needs to emerge and evolve. The darkness above is a protective cloak and a guide, revealing fundamental truths about the cosmos. It points to the Big Bang, the expansion of space, the limits imposed by the speed of light, and the structure of time itself. Standing under this dark sky, we are not merely observers. We are participants in the unfolding story of the universe, aligned just in time to witness the cosmic drama. Our understanding of the universe through the darkness of the night sky transforms the way we perceive our place in it. We are small, living on a speck of dust in an immense cathedral of space-time. The stars we see are not fixed. They are part of an ongoing process, moving, evolving, and stretching away from us. The ceiling of stars above us is not static. It is alive, dynamic, and expanding. And we are here to witness it, to ask questions, to explore. We are, in a very real sense, the universe observing itself. So, the next time you stand under the night sky, don't see darkness as a void or absence. See it as the echo of creation, the afterglow of the Big Bang, the stretched fabric of space, and the finite age of the cosmos. Understand that the gaps between stars are not empty. They are the breathing space of the universe, the necessary calm that allows life to exist, the silent record of cosmic history. Every star, every shadowed space, tells the story of time, energy, and space intertwined in a grand cosmic dance. The night sky is young, expanding, and profound. It is the aftermath of the biggest explosion in history, a canvas of light and darkness woven over billions of years. By simply looking up, by asking why, we connect to the deepest truths of physics, cosmology, and reality itself. Nature doesn't care about intuition or common sense. It only cares about the rules. And the rules tell us the universe had a beginning, is expanding, and is infinitely fascinating. Standing beneath it, we are reminded that we are part of something vast, beautiful, and ongoing. We are the universe's way of understanding itself, arriving just in time to witness the miracle of existence. The game of discovery is far from over, and the night sky is only the beginning.